being able to interpret graphs is an incredibly important skill in the sciences because that's how scientists share their data and share the information that they have learned with the scientific community. So, there's all kinds of different ways that we can graph motion. Now that we have studied speed and velocity and acceleration, there's lots of different ways that we can graph these different factors and be able to describe and get a lot of information in just a very small picture. So let's look at a bunch of different graphs. And so your goal here is going to be able to interpret those graphs. So we're going to look at a few together. And the way that this video is going to work is I'm going to ask you a question. And the best way for you to interact with it is right after I ask the question, pause the video. Look at the graph, observe the graph, analyze the graph, think of what you think the answer is, and then unpause it. I will give the answer and explain the answer. Then I'll ask another question. Pause it. Think about what you think the answer is, and then unpause it to hear the answer. Okay, that way you're using your brain, you're thinking through the process, and then you're able to see if you were correct or not. So then you can sort of reflect on your answer. Were you correct? Awesome, you've got that skill. Did you get the answer wrong? Well, let's think about why did you get the answer wrong? Why did you think what the answer was versus what the true answer is? That way you can sort of correct your thinking, okay? So that's what we want to do in this video. This video is pausing and playing so that you can interact and reflect. Okay, so please do that as we go along. And you'll also want to make notes, I'm sure, as well, because afterwards you'll have some independent practice where you will be doing the exact same thing, but for a grade. Okay, so on this graph we have distance over here. So whenever we read a graph, this is always what we want to do. We want to check out what's being measured. So here we have distance, and it's in meters. So as you go up, we are increasing distance. Okay. At the bottom, we have time. So as you go across, it's the longer the time took. Okay. So what kind of information can we see in this graph? Each of these items here provide us with information. Okay. What do you think the slope tells us? So pause the video, look at the graph, and think about what do you think slope is going to tell us? Slope is going to tell us the speed because it is meters over minutes. So this is meters per minute. So that is a speed. So the slope tells you the speed of the vehicle. What do you think a steeper slope means? A steeper slope means that the vehicle is going faster. So the steeper the slope, the faster it's going. If you have a lower slope, that means you have a lower speed, so it's moving slower. Okay. What do you think a perfectly straight line means? Like A here is perfectly straight. It doesn't change like B does. So what do you think that straight line means? A straight line means that it is maintaining a constant and consistent speed. It's not changing speed at any time, staying constant. So A remained constant the entire time that it was measured. B, however, did not, because you see that you have a change in that line. It's not a straight line, so B did not maintain a constant speed. Okay, and what do you think a flat line means? Like right here at B, it flattens out for a second. So what does that mean? The flat line means that there's no motion, so they stopped for a while. And that's because if you look, this is your distance, and so you see that from 10 seconds to 20 seconds, B did not change distance. It stayed at 400 meters. For 10 seconds, it stayed at 400 meters. That means there was no motion. It stopped moving. So for 10 seconds, B stopped moving. and had no speed. Okay? All right, great. Let's take a look at another one. All right, here we have the same graph, so still looking at distance over time, same two vehicles. Now we want to ask some questions. So, who started out faster? With the information we just got from the last slide, think about this. A or B? Who started out faster? Okay, A started out faster. And the reason why is because it has a steeper slope. And remember, steeper slope equals faster, lower slope equals lower. So A was going faster than B here in the beginning. Okay, next question. Who had a constant speed for the entire test time? That was vehicle A as well, because it has that completely straight line. Okay, next question. Describe what happened to vehicle B from 10 to 20 minutes. Okay, B stopped moving. Stopped moving. So it got up to 400 meters distance and then stayed at 400 meters distance over that period of time. So it stopped moving. Find their average speeds. So think back a couple lectures ago, we got an equation for calculating average speed. So pause the video here and calculate the average speed for both A and B. Okay, welcome back. You should have calculated out that A, okay, is you want to take that final point, so you want the average speed for the entire thing. So that final point is D, distance, 2400, divided by the total time, which was 30 minutes. So its speed, its average speed was 80 meters per minute. And then for B, same thing, going to do that last point. So we get the total distance is 1200 divided by total time, 30 minutes. 1200 divided by 30 is 40 meters per minute. So if you did not get these same calculations, get into contact with me so I can help you out. All right, here is another graph. This one is distance, meters, time, seconds. So same idea as the last one, it's distance and time. Okay. And now we can look at acceleration. So acceleration is indicated by a curve when you have a distance over time graph. Your changing slope equals your changing velocity. Okay, so take a look at this graph. We've got our speed, meters per second. At the bottom, we have our time in seconds. So now observe these lines and think about what each one of these things are going to tell you. So what do you think the slope tells you when you're looking at speed over time? That's your acceleration, meters per second per second. So meters per second squared, that's your acceleration. So if it is positive, going up, that's when you're speeding up. If it's negative, going down, that's when it slows down. What do you think a straight line tells you, such as this right here? This is a straight line here. What does that mean? That's your constant acceleration, constant. Okay. All right, so let's take a look. All right, so specify the time period when the object was slowing down. So use this graph and get the time period when it was slowing down. It slowed down between 5 seconds and 10 seconds. So at this point right here, the slope starts to go down, that means that your acceleration is going down, it's slowing down. This point is halfway in between 4 and 6, so that means 5 seconds. And then it came to a stopping of measurements here at 10 seconds. Okay, at what time period was it speeding up? From 0 to 3. So the entire time that the slope is going upwards goes from 0 to 3. When was it moving at a constant speed? So what time period was it moving at a constant speed? This flat line area is when the acceleration remained constant, and that is from 3 to 5 seconds. And when was the object not moving at all? At time 0, it's not moving because the speed, meters per second, is 0. And at time 10 seconds. So careful here, notice it says 0 and 10 seconds, not 0 to 10 seconds, right? So 0 and 10 seconds, at those measurements, it was not moving at all. All right, and that's it for today. So now you have got some independent practice. You're going to be given a couple of different graphs that it will be your job to analyze. So if you were not able to work through this lecture with me and get those correct answers, and you don't understand why the answers are what they are, get into contact with me, schedule a meeting with me. I will be happy to help you out.